This week on Quality Digest Live, we're talking bad employees and good prisoners.
That's right. Plus, are you focusing on the right things in your improvement efforts? We'll find out when we come back.
Today's sponsor of Quality Digest Live is Hexagon Metrology. Hexagon carries the widest range of quality brands. With an extensive support network, Hexagon is also your partner. Hexagon Metrology. We are metrology.
Welcome back to Quality Digest Live for November 2nd, 2012. QDL is your weekly look at who and what is making the news in the world of quality. I'm Director Sharm, Editor-in-Chief of Quality Digest.
And I'm Quality Digest publisher Mike Richmond. Okay, a story dealing with so-called conflict minerals and the global automotive supply chain kicks off our news coverage this week. The Securities and Exchange Commission recently announced that publicly traded companies will be required to report on the presence of conflict minerals in their products and supply chains starting in 2014. These minerals, tantalum, tin, tungsten, and gold, are mostly mined in Central Africa and have fueled conflict in the Democratic Republic of Congo and neighboring nations for generations. The growing social consciousness among investors, not to mention consumers, has made conflict-free the new standard. But with thousands of suppliers involved in automotive manufacturing, for example, ensuring conflict-free minerals in the supply chain is easier said than done. Tantalum, tin, tungsten, and gold are found throughout automobiles. That's why the Automotive Industry Action Group, the AIAG, has formed a working group devoted to this problem shortly after the Dodd-Frank Wall Street Reform Act, which started us down this path, was passed in 2010. Now, like hazardous substance process management, Dirk, OEMs are going to be responsible in this case for the actions and the processes of their suppliers. So
right.
Now you're talking about automotive supply chain. That's a hugely complex.
That's right.
Thousands of suppliers and products.
Well, the same as with HSPM when you're talking electronics supply chain. Yeah.
And again, the means here, the method here is that the OEMs, the people that actually sell the stuff to consumers with all these parts in it, are going to be the ones that are going to be responsible for what goes in and the actions of their suppliers. So this is a really complex issue. The AIAG is working very hard to take steps to make sure that this can be implemented by 2014. But
and this is part of the Dodd-Frank?
It's part of the Dodd-Frank Wall Street Reform Act that this level of transparency it needs to be reported from companies that are publicly traded.
And when we say liability, I'm assuming we just mean financial liability or mitigation, that sort of stuff?
I assume so. The story doesn't lay out exactly what those penalties may be, but there definitely needs to be an awareness of it, and that's where the AIAG again is coming into this picture.
This is the whole thing of, as with HSPM, as you pointed out, where we're beginning to realize that the procurement of raw materials sometimes is fraught with a lot of social issues as well. And
it's not transparent. That's the
problem.
It's
not transparent. Yeah, nobody knows where it's coming from.
Yes, so the transparency we're trying to bring to the table here with this, and hopefully that will solve the problem and help solve the problem by 2014.
Okay. Well, another story that was of particular interest to me came from Gartner. You may know Gartner is a leading information technology research and advisory company, and they have announced their top 10 strategic technology trends. Man, if it hadn't been for the S in there, that would have been perfect alliteration. The top 10 strategic technology trends today.
How about tactical instead of strategic?
Yes, exactly. Top 10 tactical technology trends for 2013. 7 of the 10, strangely enough, or maybe not too strangely, have to do with mobile devices and cloud computing, or some combination of both. But for us, or for me rather, one of the more interesting trends in that top 10, and one that actually coincidentally ties into today's TechCorner, is the Internet of Things, or IoT. The Internet of Things, whether you know it or not, is a concept that describes how the Internet will expand as physical items such as consumer devices, medical devices, physical assets, or in our case, test and measurement equipment, are connected to the Internet, often through mobile devices. So you've seen the idea where people can get on their smartphone and turn on their lights or turn off their coffee maker or whatever. That's part of the Internet of Things. But it's more than just fun stuff like that. It really reaches into industry as well. So key elements of the IoT are already being embedded in mobile devices. If you look at your phone, you'll see there's a number of sensors. You've got tilt sensors, you've got GPS, you've got light sensors, you've got camera, you've got all sorts of these things already being built into your smartphone, and there's only going to be more coming. So, and when we talk about communications, we're not talking just cellular. Many devices, including cellular phones, we're talking many devices, including pharmaceutical containers and automobiles, also contain cellular communications. And when we talk communications, we've gone way beyond cellular. We've got Bluetooth, low energy, and Wi-Fi, also with NFC, near field communications. All these are examples that you will see being used in the Internet of Things. And we're going to talk about one Internet of Thing later on in the show when we do our Tech Corner.
With Mahr, yeah.
With Mahr, that's right.
We're looking forward to that. Great. Okay, well, finally in the news this week, Zeiss Industrial Metrology is teaming up with Dunwoody College of Technology to help ensure that the next generation of metrologists will have first-class tools on which to train. Zeiss is donating a pair of CMMs as well as a complete suite of Calypso software to the school. They'll be used in Dunwoody's engineering, drafting, and design class, as well as the school's machine tool technology class. So this is further evidence that test and measurement companies, manufacturers are getting it. They understand that they've got to, if they want people to be able to step in and fill those jobs, they've got to be able to give them the tools
and the training, right?
That's
exactly.
right. So important stuff. So congratulations there to Zeiss for doing that, and for Dunwoody College to do that as well. Now, for all of the stories we just covered and all the stories we're going to be covering on the show still to come, just check on the story links just below the player page right there, and you can get more information on them. And one other thing, as the show progresses, if you have a comment that you want to send over to us that we can field live on the show, just write us at qdl@qualitydigest.com, and we'll get them on the show for you. Probably towards the end, we'll comment on anything that you write into us, and we'll circle back on that then.
So your feature, a better class of prisoner.
A better class of prisoner.
What is that all about?
That's right. Well, a better class of prisoner is an article written by Bruce Hamilton, the old lean dude, the toaster guy.
The toaster guy
is another one of his names. Bruce has got a lot of names. But a better class of prisoner, yes, better class of prisoner, written by Bruce and appeared in Thursday's issue of Quality Digest Daily. Now, the quote that this comes from, the better class of prisoner quote, comes from a former governor. I did a little research on this yesterday. Okay. Interesting. Former governor of Georgia in the 60s named Lester Maddox.
Lester Maddox.
I didn't know a lot about Lester Maddox. Well, maybe you did. I never heard of the guy very much, but he apparently battled Jimmy Carter in Georgia politics for a lot of years in the 60s and 70s. But Lester Maddox had a quote in the 60s about the horrific state of the Georgia penal system. You know, Georgia, of course, known for having chain gangs, road gangs working on the roads and all that stuff. So, so Lester Maddox was asked about the state of Georgia prisons and how it would be improved. And his quote was that conditions wouldn't improve until they had a better class of prisoners.
That's right. Dang it.
I don't really know what
Send us the good prisoners.
I mean, the
conscientious ones.
That's right. I mean, when they improve, we'll improve our system. Well, Bruce Hamilton kind of jumped off of this, and actually that quote that I just read came at the end of his article, and it kind of, everything that led up to that. But I wanted to get to the punchline first because of what the heck. So what he's talking about here is this idea that, do you want employees that are good employees, that toe the line, that follow orders, that never question authority and just do what they're told? Or do you want people that are going to question that authority? They're going to take the bull by the horns and say, no, this is wrong, and be a squeaky wheel and get the grease. Because really you need that latter person. If you want to improve your organization, you need people that are going to step forward and be willing to question authority, right? You don't want good prisoners. You don't want people that are just happy to be, you want people that, as he says, escape the cell, get out and rattle the cage a little bit and make changes. So what precipitated this for Bruce Hamilton was he got a job earlier in his career in the 80s. He got a job as the VP of manufacturing for a factory. And he was presented, when he started with this job, he was presented with a list. He was presented with a list from somebody else in the organization, some other higher up, saying, watch out for these people. These are the problem employees. These folks are going to create problems for you. And he's like, well, I'll make my own decisions about people. But he wondered, he's like, well, why? What's
a problem person?
What is a problem person? What's the matter with these particular people? Well, what he found out was that these particular people that were on this list were ones that were causing problems.
Shaking the tree.
Yeah, they were saying, hey, you know, in a certain case, the guy, you know, one of the people on the floor was complaining a lot because the guy who designed tools was left-handed, and all the tools were designed for left-handed people. He said, well, I'm going to reconfigure tools for right-handed people, right? I mean,
yeah,
you know,
makes sense.
It's a great thing to do, but I mean, nobody thought about it, and if that particular person hadn't rattled the cage, would it have even been an issue that was known, right? This is important stuff. One of the people that was a particularly troublesome employee at the time was a product tester, and this young lady was a real troublemaker. She always questioned management. She always questioned the purpose of management, and she said, managers are people who sound like they know what they're talking about, even when they don't. Well, Hamilton liked that so much.
That would be one of us, would it?
No, I hope not. Hamilton liked that so much, and he liked that person so much that he married her. Now, that's one way of getting her on board, I guess.
He calls her the Toaster Man's wife.
She's Mrs. Toast.
Mrs. Toast.
If you read the article, she's Mrs. Toast today. So the moral of the story here is a simple one, and it's a good one, too.
Is marry the troublemakers.
Marry the troublemakers. That'll teach them.
Yeah, exactly. Yeah.
That'll teach you, too. But the moral of the story here is just what we talked about earlier, which is that you have to engage your employees, and you have to understand that if employees are going to be engaged, many times the feedback you're going to get is not always comfortable. And if you're in management, you can't be too comfortable. Your employees can't be too comfortable. You can't be too comfortable either. You have to be willing to be a little uncomfortable, to try different things, and to take the feedback that people give you and honor it. Honor them, because it takes guts, it takes courage to go to management with an idea and say, hey, this is messed up, this is a problem, we got to fix this. And the people that are on the business end of the machine, that are on the shop floor, for example, are the ones who really know. And if you just want, in Bruce's parlance, or Lester Maddox's good parlance, good prisoners. If you want good prisoners, hey, you can get them. You can have an organization where nobody questions anything. You can have a good group of prisoners that are happy to punch the clock.
There goes the innovation and the continuous improvement.
That's right.
Everybody's just, okay, that's the way the boss wants it, I'm going to do it that way, and hey, I'm not going to say anything.
Sure.
You stagnate.
But who really creates that culture is the boss.
Oh, sure. Yeah, absolutely.
So if the boss creates a culture where you want people to shut up and follow orders and not question anything, you're going to get it.
Yeah.
You're going to get it, basically. You're going to get what you asked for, and you're not going to improve your organization. So that's what the moral of the story was from Bruce is look for those employees that are not good prisoners and aren't satisfied to be that, and that are going to question you and are going to help push your organization to the places where you want to take it.
That's right. And hey, let's hear it for those employees who are willing to push the boundaries even when there's resistance from managers.
That's right.
I mean, it's easy to do that when you're in an environment where management is open to ideas and you don't feel threatened by criticizing or making changes, but I mean it's really tough. And I've worked for organizations like that where there were people who were outspoken. You could tell they just gritted on every manager's rear end, but they were still willing to do it, and they were willing to speak up, and eventually, most of the time, they got listened to. I mean, if you've got good ideas, you've got good ideas, and you can't ignore them for long. I mean, if they're good ideas, right?
Exactly, you can, but
you can,
but you can if you want the company to move forward. And again, these people are the ones that are down there doing the work. They're the ones that know. You may think you know as a manager what's really going on, but those folks know.
Yeah.
And you have to listen to them and adapt, if it makes sense, adapt what they're suggesting that you do.
Yep. Okay.
Good stuff.
Good stories. Okay. The other feature story this week that was interesting was this article from Bob Sproul. Focus on the limiting factor or improvement processes will fail. This was one of those articles that you just have to love, I think, for its simplicity. This was actually Sproul's take on Elihu Goldrat's theory of constraints, and kind of smooshed together with Lean Six Sigma. Smooshed, that's my favorite word from Ryan Day,
word of the day,
our webmaster. Smooshed. And what Sproul does is to use the theory of constraints to identify the areas in a process that need work, and then you use the Lean and Six Sigma tools, or PDSA, DMAIC, whatever, if Six Sigma is a bad word to you. You use these tools then to help reduce the waste in those steps, the waste and the variation within those steps that you've identified using the theory of constraints. Now, just to refresh people a little bit, the theory of constraints has been around since the mid-1980s. It's an interesting book to read. It was by Elihu Goldrat, and it was introduced in his book, The Goal, a Process of Ongoing Improvement, otherwise just normally known as The Goal, by Elihu Goldrat. And in here, Goldrat identified 5 focusing steps. And I think we've got a slide for that. The first one is identify the system's constraints, and we'll get to what a constraint is in just one second. Decide how to exploit the system's constraints. Subordinate everything else to the above decision. Elevate the system's constraints, and if in the previous steps a constraint has been broken, go back to step one, but don't allow inertia to create itself a system constraint. So what do we mean by constraint? And the easiest way to think of this, Sproul has a pretty good analogy. So let's look at a water pipe. So if we bring up our little slide here. Think of this as a water pipe, and you see there's narrow pipes and wide pipes and a narrow pipe and maybe a medium-sized pipe. The idea is if you're trying to pump water through this, water can only go through at a certain pressure, at a certain flow, through a certain diameter pipe. The limiting pipe in this is the smallest pipe. The next limiting factor is the next size pipe up. So it doesn't matter how much you push on how much pressure you try to put on this system, you're going to be limited by the smallest pipe. If you try to increase your flow through the pipe by widening one of the pipes that's already wide, you're not going to have any impact because that isn't where your constraint is. You have to find the narrow pipes, widen those pipes, and at that point you're going to start increasing flow. Now, he has actually a pretty interesting example of this. He looks at a real example. He says, let's take a look at an emergency room. And let's look at the first few steps. And we're going to assume here that a patient enters an emergency room. They have a certain amount of wait time, let's say 20 minutes. Then the doctor examines the patient. Let's say that takes 30 minutes. If the decision is, hey, I see some issues here, we need to send out for labs, then sending out for the lab may take 90 minutes. Okay, so what you need to identify is, okay, where is the constraint in this system? So you can say, okay, well, so we know that people don't like waiting in waiting rooms. So they come in, the nurse says, thank you, you sign in, you say, be seated. And you wait for 30 minutes before you see the doctor, or 45 minutes before you see the doctor. And you go, oh, gee, I hate waiting that long to have to see my doctor. I wish they'd speed that up. So customer complaint kind of drives us, oh, we got to go and we got to speed up how long people are waiting to see the doctor. And they put in some processes and so forth. And sure enough, 5 minutes within walking into the emergency room, you're seeing a doctor. Then guess what happens? You see the doctor, you spend 30 minutes with him, he sends out for labs. What do? You go back into the waiting room and sit for 90 minutes. And by the way, everybody else is being processed really fast. So what happens? The waiting room starts to queue up because you're still constrained by how long it takes the labs. If you want to get people through there first, forget about how long it takes to wait the doctor. You can deal with that one later. Take care of how long it takes to get labs. Once you get that down to, let's say, 30 minutes or 20 minutes, then you can say, okay, what's the next constraint? Well, now let's look at the waiting room. Let's look at the patient input time. Now let's look at if we can speed up that process from the time a patient walks in the door to the same time they see a doctor. But working on that before you've taken care of the labs time just doesn't make any sense.
Sure. Going back to the water pipe analogy, I mean, if the thinnest pipe is not expanded, it doesn't matter what you do with the fatter pipes, the wider pipes. I mean, you have to work on the first one, the ones that's thinnest, the bottleneck first, and then you can deal with the other issues later.
And by the way, very often you see kind of the theory of constraints dealt with when you're talking about time. In this case, we're talking about wait time. It doesn't have to be that. You can have a bunch of machines responsible for making a part, sequential machines. This machine does this machine does that, this machine does this. At the very end, you say, I've got a lot of variability in my process. And you go back and you examine your machines and you go, oh, this machine's got variability, I'll work on this one. Well, if that isn't the machine, that's, even though it's perfectly valid to try to improve that machine, that one single machine, if that's not the machine that's the constraint in the system, you're wasting time and energy. You need to find the machine that's really the constraint, improve the variability on that machine. That'll improve your overall process capability. Then you can go back and start fine-tuning the other machines in the process. So,
interesting. Theory of constraints has really been pretty long-lasting now. It's been almost 30 years.
It has. You don't hear people talk about it a lot, but it is really common sense. You got to find the weakest link in the chain, work on that first.
Sure, the bottlenecks, the pain points. I mean, it's another way you can look at pain points or choke points, whatever it is that is stopping you from being more efficient. Work on those, and then you can work on the things that are less, that are already working better, or already not constraining you as much. You can work on those things later. I mean, you have to still work on them, but you can work on them in order. Great, good stuff. Good stuff. Okay, thanks.
Very interesting.
Okay. Well, we're going to turn now to our Tech Corner. And
Sure.
Tech Corner is a good one this week because it's from Mahr Federal. And Mahr has given us a pair of products that, well, actually one product, but there's a couple of applications for it. It's the MarSurf RD18 and I think it's the MarSurf, is it the MarSurf 1 app for Android, I believe, as well. And we're going to see them right now. Dirk's going to show them to you on the Tech Corner set. So, yep. Dirk, take it away.
Okay, let's go. Okay, so we talked at the top of the show, we were talking about the Internet of Things. And I said we're going to have an example of an Internet of Things. We've had these on the show before where you have a device, a test and measurement device. We've had DVMs, we've had optical alignment tools, we've had other tools where the control or the data collection for that tool is your, let's say, your smartphone or your tablet. So we're going to look at another one of these today, and this one happens to be from Mahr, and this is going to be a surface measurement device. In this case, we're looking at the MarSurf RD18. This is a surface measurement drive. Keep in mind, this is just the drive, and where you'll see how it is going to be controlled by a Motorola tablet. Now, in the past, when you wanted to control one of these, and still now, if you wanted to do a lot of data analysis on surface roughness, you would use the RD18 with one of the other Mahr surface measurement systems, which may include a computer, a monitor, some higher-end software that does a lot of analysis on the surface measurement data you're taking. And of course, those come with a higher price. If all you need to do is simple surface measurement, you need to just scan a surface, get your surface roughness parameters, maybe generate a report, and that's all you need to do, why pay for a whole system? And that was Mahr's thinking when they came up with an app, an Android app, to control this device, so you don't need the rest of the system. All you need is the RD18, and in this case we're going to use a Motorola tablet. So let's take a look at how this works. This is really pretty straightforward. If we go to the gauge cam down here, we can see we've got our get it in front of the camera here. This is our RD18. This is just a drive unit. You can see all it has on it is a big green button. I'm going to press that button. That's going to establish my Bluetooth connectivity. I'm just going to wait for a solid blue light there, which tells me that I've got my Bluetooth connection to my tablet. And there we go. I'm ready to go. I'm going to launch the Mahr 1 app. Let me orient this so you guys can see that. Hold on. Come on, spin around. Oh, I guess I had it upside down. There we go. This is the Mahr 1 app. I'm going to select that device, and my app will launch here in just 1 second. And that's it. I am actually ready to start taking measurements right now. All I have to do is, you see in the lower right corner, I've got a little play button. I press that, and now it's going to start taking the scan. As I'm talking here, it's taking the scan, and it's drawing me a little trace. Oops, move this down a little bit. It's drawing me a little trace in capturing my data across the screen. Now, in the lower left corner, you see a 5.6 there. That is the travel distance for the probe. I can select any travel distance I want there up to the travel length of the skid on the RD18, which I believe is 17.5 millimeters. I have it selected for 5.6 just to keep the scan short here. Now, once the scan is done, you can see at the top, and I'll hold it a little closer to the camera here, you can see I get a trace that shows the surface profile of the scan that I just did. And also, down below, we can see, get it into the camera there, we can see the various surface parameters that we just measured. We measured RA, or calculated, I should say, RA, RQ, RZ, Rmax, and RT. That's all there is to it. That's how simple it is. Right out of the box, push the button, within a few seconds you're taking surface measurement data. Now, if I want to save this data, which I do, create a report, all I do is click my little save button down there. That data is stored as a report inside my tablet. Now, let's take a look at some of the settings. I'm going to go into my settings, straightforward Android interface. You're all probably familiar with that, if you have an Android. I have some options here. I can get this where you can see it. I can decide where I want to store my data on the device if I'm saving it. What units do I want to use, metric or inches? Let's take a look at this one. What I want to calculate, and I have my choice. I can select, RA, RQ, RZ, Rmax. I simply put a checkbox next to the ones I want to display. I have them all selected right now, but I didn't have to do that. I could have selected just one of them, and we'll go back to our other screen. And also you can select what kind of file you want to save. So that's how easy it is. But there's another thing. Let's go back to our regular camera here, Daniel. The other thing that's really cool about this, one thing I'm seeing more and more in portable devices is where the calibration reference is stored within the device itself. Now, if you've used some older surface measurement devices and comes time you need to calibrate them, you know what you do. You go to your tool crib, you take out your little plastic box that has your reference, your surface reference tabs in them, you bring them back to the tool, you put them down, you handle them very carefully because they're typically small, and you try not to damage them, scratch them, or anything like that. You take your calibration measurements, put them back in the case, put them back in the tool crib. That's all very nice and well, unless you lose those references or unless you scratch them, get something on them. Much better if the reference is stored inside. Let me show you something. I need to do a calibration on this. I rotate the probe 180 degrees, retract it back inside. I'm ready to do a calibration. Let's go back to the gauge cam here. I click calibrate on the bottom, and it comes up. First thing it asks me is to say, well, what kind of calibration am I doing? I have my choice of RA or RZ. I simply look on the bottom of the device, and it tells me, here we go, it tells me we're going to do an RZ measurement, and the reference is 9.46 microns. So I simply come back here, I select RZ, I type in 9.46. I tell me how many passes I want. I'm just going to say just one pass just to keep things going. And that's all there is to it. I hit go, and it is going to now do a scan of, it's going to do a scan of the device, and it's being done internally. If it was doing if we can come back to the main camera here, if it was doing multiple passes, the software would prompt me each time to initiate the next pass until all three, let's say 3 passes were done. In this case, I only did 1 pass. Once the pass is done, if we come back to the gauge cam here, it shows me that I can accept my calibration, gives me my calibration corrections that were done. I OK it, and I'm good to go. I'm ready to start measuring. And also, if I want to look at my data, I can simply go into another app within my Android, let's say in some sort of office or business app in there. I can go out to that PDF file. I can bring the PDF file up for reference. I can read it. I can email it. So you have all the same options that you normally would have with any other app or any other document that is stored on your device. Now remember, I did this on a tablet. Could have done it on my Android smartphone just as well. So you're seeing more and more of this, and you're going to continue to see more of this, where industrial instrumentation is becoming part of the Internet of Things, where why pay for a user interface when you already have a computer in your pocket capable of being a user interface? Why not use your phone or your tablet and pay, rather than pay more money to get a system that perhaps you don't need for your particular function? And again, that was the market for Mahr's product here. So again, great little product from Mahr. This is the RD18 surface measurement drive, along with the the MarSurf 1 Android app. Great little tools from Mahr. And by the way, the RD18 is just one of a series of surface measurement tools that that Mahr sells. They have a whole variety of surface measurement from kind of a handheld like this to higher up instrumentation. So thanks to Mahr for sending that to us.
And thank you, Dirk. Great stuff there from Mahr, and thank you again for Mahr for sending that. The MarSurf RD18 and the MarSurf 1 app for Android. Both a couple of great tools there that we looked at on this episode of TechCorner. This version of TechCorner this week. So Dirk, yes, thank you for doing that. That's a fun little TechCorner.
Yeah, I will say that also, this is just kind of a funny little story. This is obviously a demo unit they sent us. Mm-hmm. It happens a lot of times, you'll get a demo unit and there won't be an instruction manual because somebody forgot to put the instruction manual in there. Mahr. Okay. But it's great. It's great because I got an email from one of the engineers and said, oh, no problem, it's just, he gave me like 8 steps. He said, oh, that's all there is to it. Yeah. No manual. Yep. Took the thing out of the box, kind of read his like, well, push this button, do that, and open up the app and it'll be self-explanatory, and it was. I mean, literally, I was running this thing within taking surface measurements within about 10 minutes
Wow.
of getting the box from FedEx.
Great.
So I mean, so even without instructions, so simple. Even an editor-in-chief can do it.
I was going to say, even Dirk, well,
Even I can.
the question is, could I do it? But I mean, you can do it. That was great.
Yeah.
Great stuff there from Dirk and from Mahr. So thank you, Mahr, for doing that. Okay, well, that's our show for the week. But before we close, we have another important thank you to Hexagon Metrology, who is the sponsor of our show this week. So thanks to Hexagon. We'd like to thank them again. Hexagon Metrology is committed to helping you control your processes, enhance the quality of your products, and increase efficiencies. They empower you to stay one step ahead of a changing world with their wide range of product offerings, nearly 200 years of expertise, and an extensive support network. Hexagon Metrology, where quality comes together. So to find out more about Hexagon Metrology, just click on the banner ad below or to the right of your player page right down there.
That's right.
That's right.
Okay, well, thank all of you for joining us today, and thanks to Mahr for sending us equipment and our articles from Bob Sproul and
Bruce Hamilton.
And
Yep.
Bruce Hamilton. That's right. Great stories from those guys. Be sure to tune back in next week. Be another great show, and we have some interesting articles coming up next week.
We sure do. We sure do. So check that out. Come back and join us on Monday for QDD, and we'll see you next Friday here for QDL.
So long.
See ya.
Thank you.